Hello everyone, myself Anshpreet Singh and today I will be presenting the task 7.1 that is communicate with the robot. Coming on to the brief overview, as an extension of my previous task 6.1, I have further enhanced my Arduino based rover project to create an even more sophisticated and feature-rich robot. Building upon the foundation of many different hardware components, my rover offers an enhanced user experience and improved functionality. With the integration of an IR sensor, my robot is now equipped with obstacle detection capabilities. Whenever the sensor detects an obstacle in its path, the rover stops and moves backwards for a duration of a few seconds. This obstacle avoidance feature ensures the safety of the rover and prevents any potential collisions. Furthermore, I have integrated a sophisticated LCD display using an I2C module into the design. This display provides real-time visual feedback. It showcases the current direction of the rover, whether it is moving forward, backward, left, or right. By extending the capabilities of the rover, I have created a more versatile and interactive robotics project. With wireless control through the Bluetooth module, precise speed regulation using the potentiometer, and the added safety feature of obstacle detection, my rover combines both functionality and user-friendly operation. Component used for this project includes Arduino Uno R3, L298 and motor driver, HC05 Bluetooth module, potentiometer, IR sensor, LCD display, I2C module, breadboard, DC motor, chassis and tires, and jumper wires. And for the software part, I have used Arduino IDE and Arduino based Bluetooth software. Coming on to the connections and working, the rover's motor driver allows precise control of the motor's speed and direction by connecting their positive and negative terminals. Four of the six jumper wires connect the motors to the Arduino, while the remaining two connect the potentiometer's EN pins. By connecting the potentiometer to A node of the Arduino, the user can regulate the speed of the motors with ease, while the rest of the two pins of the potentiometer are connected to the 5-volt and ground of the Arduino respectively. The Bluetooth module connects to the Arduino's RX and TX pins, providing wireless communication to control the rover from any Bluetooth-enabled device. The rover receives power from a battery, and the Arduino distributes the power to the rest of the device through the breadboard's positive and negative terminals. Once the program is uploaded to the Arduino board using the IDE, the rover is ready to move. Overall, the rover's various components work together seamlessly to allow for wireless control and precise movement. With its educational and versatile nature, this project is a great way to learn about electronics and programming while building a fun and functional device. When it comes to the IR sensor, I have connected its output pin to my IR1 pin on the Arduino. This sensor is crucial for detecting obstacles that may be in front of me as I navigate my surroundings. Once connected, the IR sensor actively monitors the environment. When it detects an obstacle, it notifies me by setting its output pin to high. This indicates that there is something in my path that I should be aware of. In my code, I have made changes such that whenever the IR1 pin is set to high, my rover takes immediate action. It stops the movement and moves backward for a duration of 2 seconds and then proceed with the Bluetooth control once the obstacle is cleared. For my LCD display, I have a I2C module that simplifies the connection between the display and my Arduino. To establish the link, I have connected the SDA pin of the I2C module to the corresponding SDA pin on my Arduino. Additionally, I connected the SCL pin of the I2C module to matching SCL pin on my Arduino. Coming on to the description of the code utilizes two libraries, the Liquid Crystal I2C library and Wire library for I2C communication. We start by defining the pin connections for various components. The motor pins M1, M2, M3, M4 are connected to the motor driver to control the car's movement. The IR sensor pin IR1 is connected to an infrared obstacle sensor to detect obstacles. In the setup function, we set the motor pins and IR sensor pins as input or outputs. We initialize the serial communication at a baud rate of 9600 and the LCD display. The loop function is where the main action happens. Here is how it works. We read the potentiometer value from analog pin A0 and adjust the car's speed based on it. Whenever the sensor detects an obstacle in its path, the rover stops and moves backward for a duration of few seconds. The available Bluetooth signals and their action include moving the car forward, backward, left or right, or stopping it. We update the LCD display with the current action. The code includes several movement functions to control the car's movement. Forward to move the car in the forward direction, backward to move the car in the backward direction, left to move the car to the left direction and right to the right, and the stop function to stop the rover. That's it for the code explanation. Thank you. Now I will be demonstrating the working of my rover in the physical mode.